Hi everyone and welcome to the 10th episode of our Fusion 360 training series. I hope you're keeping well during this pandemic. I hope you're washing your hands. Today we're going to be having a look at the next steps. We're going to be using the things that we've learned and we're going to be using them to actually create something that we'll use in real life, something that I have created in real life, something that I've used before or used regularly. This is a stand for a laptop. That's a mesh of the laptop that I have. And this is a 3D printed stand, and it's got a couple of cool features about it. So I'm going to go ahead and hide the laptop. So the first cool feature about this laptop stand was that it had a VESA adapter on the back. A VESA adapter is just a standard connector that you can use to mount things like screens and laptop stands and speakers and whatnot. And so what I could do was connect this laptop stand to the stand of a screen and use my laptop as a screen. The second cool feature about it was that it was too big for the 3D printer that I had, which isn't so cool. But the cool thing is that I could separate it into separate bodies and dovetail them together. So I printed out each body by body, and then I snapped the pieces together to make the final stand. So that was the stand that I had originally made, and I've got it right in front of me, and it works really well. However, I've got now access to CNC machining tools. So what I want to do is recreate the stand in metal to make it a smaller profile. And that's what we're going to be doing today. So let's go ahead. We'll first start by inspecting our mesh for the laptop. Always important to do when you begin. So we're going to inspect the width by clicking inspect that point there and that point there. And we can see it's about 149 mils wide. This is a catastrophe. I happen to know that the laptop is in fact 422 mils wide, so the scale is wrong for this mesh. So how can we fix it? Let's go ahead and firstly calculate the correction factor. So we'll say 422 mil divided by 149. And what we can see is that we'd have to scale it up by about 2.84 mil. 2.84 times in order to get the proper scale. So let's go ahead and do that. You might notice that the mesh environment is missing up top. To get into the mesh environment, we choose our mesh, right click and say edit. Here we can come along now and say modify, and we'll say scale, and pick our mesh body, and then use the scaling factor 2.84. Lovely. Now our mesh is the appropriate size. We'll save that. And let's go ahead and go and start creating our laptop stand. So we're going to turn on our origin so we can orient it properly, and we'll drag in our newly scaled mesh. Beautiful, excellent. Let's go ahead and right it for the moment. So we'll say 90 degrees, look at it from the front, and we'll drag it up so that it's approximately in the middle, approximately above the origin. It doesn't really matter all that much. And we're going to rotate our view and have this rotated. I want this to be 30 degrees tilted forward, like that. The difference between this and my old adapter is that I want to have the VESA adapter on the bottom. Okay, so let's go ahead and get started. What we want to do is create a work plane. We're going to say construct, and we're going to say plane and angle, and we're going to pick that axis there, and we're going to orient it so that it's parallel with the bottom of the laptop. So we'll say negative 60 degrees. Next, what we'd need to do is, well, I can cheat. I can use the inspect tool to get the exact distance. But what we're going to do is create a offset plane from that angled plane. Look at it from the side. And no, yeah, 110 should do it. Let's make it 111. Beautiful. So we've made a plane that happens to run parallel and touching the bottom of the laptop there. I'm going to turn off the origin and the early construction plane. Now, let's go ahead and create a sketch on that plane that we just created. For some reason, I've got it switched off. It's not automatically looking at the plane. If you need to look at the plane, you can click this button to look at. Beautiful. Now, what I want to do is I want to outline the laptop stand. I want this to be a pretty tightly conforming laptop stand. So let's go ahead. We'll go ahead and create this geometry. In fact, I might start from the most critical part, which is this point here, the pointy front of this laptop. So the reason why creating this laptop stand was a little bit of a trick is if you want it to be angled, then it needs to be able to catch the front end. Because the front is pointy, you need a pointy laptop stand as well. So let's go ahead and create it there. I think that the designers would have made a proper angle on the front. So it might be 3 degrees. Go ahead and drag that down. Maybe it's not 3 degrees. Maybe it's more like 2.5 degrees. What do we think? It's looking pretty good. 2.75, 2.8, 2.9. Too much, 2.85. 2.85 degrees. That looks pretty good. Excellent. Okay, so what we're going to do is finish off this stand. So we'll come along here and we'll choose that edge there. And we're going to come down and apply a vertical constraint to there. And we'll use the trim command. Oops. We'll connect them both and use the trim command to get rid of the excess. Lovely. Okay, so you see we might look at it from the bottom. There we go. Okay, so looking pretty good. And let's go ahead and finish this off. We'll come along here. It's going to be pretty rough actually. And what I want to do is mirror this about this plane. So what I'm going to do is select those lines that I want to mirror, create, mirror, and then say mirror about that line. Lovely. I'll close that off. And there we have our profile for the base of this laptop stand. Go ahead and extrude that down. We might make it 3mm steel. So it's going to be a bit, oh, that might be a bit heavy. Let's go ahead and make that out of aluminium. We'll say 2mm, yeah, 2mm aluminium. No, 3mm aluminium. Very good. So to change the material, we'll come along to modify, and we'll say physical material. And here we'll come along to metal, and we'll just go ahead and grab aluminium. Not too concerned with the grade. 6061. Lovely. Okay, what we want to do next, if we were to make this out of aluminium, it wouldn't be able to sustain this angle. The laptop would slide forward. So what we need to do is create a catch. So to create a catch, what we're going to do is come along to here, and this isn't going to be sheet metal. This is actually going to be machined. So let's go ahead and create a sketch on the front here. We'll use the lookout tool. And as before, what we're going to do is create lines on here. We want to project those 2 lines. And what we want to do is offset. So we can say create offset. And if we were to click the line from the get-go, it would chain the entire loop. It's not very useful to us. So what we want to do is click modify, offset, and untick chain selection. Here we'll go tuk, tuk. Lovely. And to be homogeneous with the rest of it, what we're going to do is add in a 2mm offset there. Lovely. So we've got a 2mm offset. Let's go ahead and close this off. So we've got vertical lines coming down there and down here. Beautiful. I'm not going to worry about these. I could trim them off if I want to. Let's go ahead and trim it off because I do want to. Pedantic is good. Okay. And let's go ahead and extrude this up. So we're going to extrude it in 2 directions. The first direction is going to be used to catch the front of the laptop. So I could, let's go get it to the top. Why not? We'll say the 31.5. So just shy of the top. And we want to also extrude it. So we'll change the direction to 2 sides and extrude it downwards so that it connects to the rest of it. So 3mm down. Oh, that's right. It was 3mm, not 2mm. So say that I wanted to increase that offset. I could go back in time and edit that sketch. Find my offset. So we'll come along here and we'll change that from 2 to 3. Just make sure. Yep, 3 millimeters. Lovely. And there we have it. There, it's 3 millimeters thick now. Okay, so looking pretty good. So it could use some improvement. There is actually a taper angle on there. Now what we could do is we could correct the taper angle by using a drafted surface. So we could say modify, and here we can say draft. Hopefully I'll get this right the first time. Pick the surface that I want to draft to, and then pick the 2 surfaces that I'm drafting. And ooh, very nice. However, I want to flip the direction, and oops, not that one either. Let's go ahead and be more careful with how we pick the faces. So we'll say that's the surface we're drafting to, and we want to keep the top fixed, so we're going to choose the bottom. Nope. Let's try again. Okay, it's being a little bit annoying. We can do this though. We will say draft. So close, but tell you what, we'll actually do it. The first thing that I want to do though is measure the actual angle of deviation. So say that we wanted to, we'll say create a sketch on the side here, just as an approximate. And here we could say, we'll hide the bodies. That sounded a lot more sinister than I intended. And say that that's approximately parallel. That draft angle, oops, that draft angle is about 75 degrees. So we'll say draft. Oops, get out of the sketch, modify, draft. Pick that face, pick the draft. Seems to be not talking to me at the moment. That's okay, I'll come back to it later. So let's go ahead, we'll add in some fillets here. No, I want the draft, We'll say modify, draft. Pick the static face, pick the faces that we're moving, and let's go ahead and we will, let's go ahead and make it thicker, and then we'll add in the draft. We'll say 6 mil and 6 mil. Might actually be more like 12 mil. Modify, draft, pick our static face, pick our angling faces, and let's go ahead and, there we go. We'll add in our 15-degree draft. Beautiful. We might want to do a counter draft on the bottom, so we'll say modify, draft, flip the direction. Oops. Modify, draft. Actually, that's okay. I can capture it with a fillet. Okay, so we'll put a 32 mil fillet on the front. Let's go ahead and fillet that up. A bit chunky, actually. Modify, draft. There we go. That's it. Perfect. We'll say negative 15 degrees. Beautiful. Lovely. Excellent. Cool. And say that we want to move it in the direction, but we don't want to fluff around with all of that stuff again. Let's go ahead and say move, and we're going to pick these faces. Oh yeah, very good. Okay, so we're going to say move this guy here, these faces, and for our pivot, what we're going to do is pick the center of this bottom here. And if we did it all just right, we should be able to, whoop, nope, not yet, that's okay. We'll say, we'll get rid of that fillet actually. I think it's being problematic. Nope. What if I move faces? Yeah, move faces, that one, this one, and this one. And hopefully this time, whoop, yay, there we go. Lovely. So we'll just move it so that it's conforming nicely with there. Excellent. So there we've got our stand. We'll go along and we'll add fillets into here. Maybe a fillet on the, no fillet on there, that's dangerous. We'll say fillets along the bottom here. Excellent. And we'll go ahead and add 20 mil fillet on the front, and we'll leave the outside to be sharp like that because that looks cool. All right, so let's go ahead. We'll add in some small safety fillets onto the front. We'll say 2 mil. 2 mil. Ooh, looking good, looking good. Maybe 1.5 there. Excellent, excellent. So it's looking more how I want it to now. Excellent. So we've got our base, we've got the base. Now what we want to do is make the visa adapter. So let's go ahead and we'll quickly draw on the bottom. And this time what we're going to do is project the top and sides so that we can centrally align our visa adapter using points. So we'll create point there and there. And let's go ahead and we'll create a center point rectangle. Center point rectangle, 10 by 10. 10 centimeters by 10 centimeters, so 100 by 100. There we go. And I'm going to use the vertical horizontal command to position this in the middle, there and there. Lovely. Now, these are actually going to be the center points for our visa adapter. So what we want to do is offset it. And this is going to represent our base. So we'll say center point rectangle. And we might say 150 by 150. Beautiful. So let's go ahead, we'll extrude that out. It doesn't have to be all that big. We'll say 20 mil. Lovely. And onto that platform, what we're going to do is create our points. So we'll go ahead and, as before, project the edges. There we go. Center point. Project. There we go. Place a point. Place a point. And we're going to vertically align, horizontally align. Beautiful. 100 by 100. Great. And all this is going to do is place the points for our holes. So we'll go ahead and create 4 points there. 1, 2, 3, 4. Lovely. Okay. Next, let's go ahead and make our holes. So we're going to put our M4 holes on these 4 points here. 1, 2, 3, 4. Great. And we're going to say it'll go 18 mil into it. Beautiful. It's going to be fully tapped. It's going to be M4 isometric. Looking good. Excellent. Pointy bottom. Tapped. Good, 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 good. Lovely. So there's our visa adapter. Now, if we wanted to make it a little more lightweight, what we could do is probably remove some of the material. So let's do this in a creative way. We'll go ahead and add in our fillets first. No, we'll leave the inside flat. Yeah, that sounds good. That sounds good. We'll make that 32, maybe 24. Beautiful. And let's go ahead and add in a fillet onto the outside. And we'll say 20 mil. Ooh, it's beautiful. Excellent. Okay, so looking pretty good so far. We might want to revisit that later. It could be really cool if we make it like a generative design or something. We'll go ahead and add in a small chamfer here just to get rid of that sharp edge. We'll say 0.5 mil. Excellent. And lastly, let's go ahead and just remove some of the material from the inside. So we'll go ahead and look out that and might grab that, uh, project that face there, offset the whole thing, and maybe just remove this internal material because it's not really required. So we'll say extrude, distance to object. There we go. Add in some fillets. Beautiful. We could probably get rid of more. Let's go ahead and change that to -32. Lovely. Cool. So there we have our laptop stand. It's going to be a lot smaller profile than our original laptop stand, massively over-engineered in some ways, but nonetheless pretty. So let's quickly have a look at how we could machine this thing. It's going to be a pretty thin profile, so it'll be an interesting machine job in reality, but it should be easy to program. So let's go ahead and go over to the manufacturing environment. We'll come to manufacture. And what we're going to do firstly is set up our stock, what we're going to be cutting it out of. So we're going to make sure that our operation type is set to milling. And here, we're not going to go by the model orientation because the model orientation was actually 60 degrees from the horizontal. So let's go ahead and we're going to pick x-axis and z-axis. So for x-axis, we can just pick any one of these edges. And for x-axis, we can pick this edge here. All good. Lovely. Um, Oops, I think I've chosen that wrong. Let's go ahead. Z-axis is facing up, so we can pick that vertical surface there. That's it. And for the x-axis, that edge there will do. Beautiful. Here we can play around with our stock points. So say, for example, if we're machining from the solid block and our 0, 0 is in the middle or in the corner there. Let's say the corner. Beautiful. Okay. Actually, while I'm in town, we might make the top a little bit taller. So let's go ahead and say that the side is a 2 mil offset and the top is 2 mil offset and the bottom is 0. Beautiful. So that's going to be the stock from which we're going to cut this stand. I could add in some vents, but let's get to it. All right, so the first thing that we want to do is a facing operation. So we'll pick the facing tool, come along and pick our machining tool. And here we've got a huge library of things, of machining tools, but we'll use the samples. Let's go ahead and find, here we go, milling tools, and we'll find a face mill. If this UI looks different to what you're used to, this is because I've turned on the latest iteration of the UI. You can find it under the experimental features in the preferences tab. Okay, so we've picked the face tool, and what we're going to do is come to passes, and here we're going to have a pass extension of 25 mil so that it overextends. Lovely. So let's see what that looks like so far in the simulation. We'll come along here. We'll say, click the simulate button. Turn off the toolpath, turn on the stock, and change the color so it looks pretty. Excellent. Now let's have a look. We can see the tool comes in here and starts to face out the material. Good. Very good. Okay, what we might want to do next is make a contour. So run along the outside and capture the contour. And it's going to be a little bit tricky because that's actually on an angle. So we've given ourselves a pretty diabolical thing to do here. But we'll just start off with the basic contour. So we'll say 2D, and we'll say 2D contour. And this time we're going to choose a milling tool, and we'll find as long of a tool as we can find. That'll do. Lovely. And click, oops, contour selection. We'll pick the entire outside. There we go. And let's have a look at what it looks like so far. Good. Okay. I have to edit that contour so that we can capture more of it. We'll come to the chain and just make sure that it grabs all of that as well. A little bit tricky with these fillets, but we can make it work. That's looking better. So let's have a look at what it looks like so far. We'll come along, we'll machine the surface. Pretty rough, actually. Pretty rough. Oof, hideous. Absolutely terrible. Tell you what, I'm going to hit this with a hammer. Let's go full 5-axis and make it do it for us. We'll come along here with adaptive clearing, and we're going to come along with a bull nose cutter. So we'll say milling, bull nose. Actually, yeah, bull nose. And we'll choose a 6 mil radius. No, 10 mil. 10 mil. Yeah, big. Good. Maybe a bit bigger, actually. Come along, choose tools. Come along here, milling, bull nose, 20 mil. There we go. Lovely. And we're going to do a 3D adaptive clearing operation. So it should pick the entire thing. And I don't think I've played around with retraction policies or anything like that. So it's just going to be pretty slow, but it should do the job pretty well. Let's have a look. It's still generating layer by layer. Yes, yes. Many, many retractions there. Could definitely use some cleanup. But it's doing the contour and it's doing the inside. This will do just fine for the top operations. Beautiful, excellent, wonderful. Let's go ahead. And I might actually quickly change the to minimum retraction, and I'll keep the stay down very high and very good. Stay down level the most. Beautiful. And let's have a look. Stay hydrated. Ah, still generating, still generating. Still going. I could have used both ways cutting to speed this up a little bit. Generating the different levels. Still calculating. In fact, while that's calculating, I can go ahead and start generating the next toolpaths. So what I want to do is have a toolpath at the end that comes along here and will, how to say, cleanly cut these slopes and this face here. So we'll come along here and let's go ahead and do a, what would be nice for this one? We'll say steep and shallow. No, yes, yes, steep and shallow. And what this is going to do, we'll use the same tool. It's going to come along and detect the flat portions and cut them automatically. It's still calculating. There we go. Come on, you can do it, Fusion. Still calculating, but it's getting there. I'll edit the steep and up there. It's already created the steep and shallow calculations. So I believe that this is part of the advanced toolkit. 10 out of 10 do recommend it. It's a fantastic set. Here you can play around with the contouring that it does on the flats, and it can increase the resolution in the steep and shallow portion, in the steep portions. So as you can see there, it takes its time. Rather than doing these wide swaths, it does this very, very incremental approach. Eventually. I'm not going to tempt it by changing the retraction policy on that one because we might not have too much time. So that handles the top operations. What we need to do as well is machine the bottom of this thing. So what we're going to need is a second setup. So let's go ahead and we'll create a second setup. And this time we're going to do the same thing. We're going to change the Z axis, but this time Z is going to be up in that direction. Our stock point is going to be in that corner there. And let's go ahead and say that the stock point will not be. That's okay. Stock point in that corner there. That's going to be our x-axis. That'll do. And we'll say our material on the top is going to be 0. So it's already going to be flush. Hey, our adaptive finished. Lovely. And it's going to use our proceeding. Okay, so let's go ahead and quickly go back to our setup one and look at our operations so far. So we'll click simulate. Come in here and we're going to greatly speed this up. So this is our adaptive clearing operation. Oh, it's beautiful. You can see it cutting it, roughing it out of the metal. Oh, so lazy, so effective. Wonderful. Yes, good, excellent. Oh no, I've left a little chunk there. What I'm going to have to do is clean that up. In fact, I'd go so far as to say, let's go ahead and turn on the comparison. Uh, there we go. That there are some bits that I do definitely need to clean up before I continue on the next one. So delete that setup. Let's go ahead, steep and shallow. Come along here to our shallow. And let's go ahead and find our passes. Great. There it is. And overlap distance. So here, what we can do is change our overlap distance. I might say 20 mil, and maybe change our step over to 6 mil. While we're at it, we can change the retraction policy. So we'll say minimum retraction, and looks good. Let's try another steep and shallow. See if that makes it a little bit prettier. Ooh, that should be much better, much better. I can see a little bit of an island still there. So let's go ahead and one more time. Let's go ahead and say 10 mil. Let's step over 3 mil here. Oh, that's gonna look cool. Okay, wonderful. So we'll go ahead, simulate it. And again, we'll change it to material. We'll fast forward it. Beautiful, excellent, lazy. What it's doing is roughing out all the material. I'll just pause it at the end of the roughing operation so that we can see how much material has been removed. So if we change it to if we change it to comparison, we can see that there's still quite a bit of material to go. And now it's coming in with a steep and shallow, and it, ooh, very, very nice. Cuts away the material. Looking good. That's excellent. Okay, so we'll go ahead and do our second setup. So the one on the bottom. So we'll come along here, setup, and what we're going to do is we're just going to have stock from proceeding setup. That's pretty cool. We can have the proceeding setups output as the input for our current one. Model orientation, Z, X, and the stock point we'll just have in the middle. We'd in reality have to change that. Okay, so again, let's go ahead and do the lazy thing. We're going to do an adaptive clearing operation using the same tool. And going to be maximum lazy and just click OK. There we go. So what it's doing is it's clearing out all of these sections and clearing out that fillet, clearing out that edge there. But what we'll need to do as well is another steep and shallow. Steep and shallow is wonderful, friends. It basically does all the work for you most of the time. So let's go ahead, step over 4 mil, and the overlap distance 12 mil. Sounds good. Another steep and shallow. And what I want to do is, after this, come in with a drilling operation that's going to drill out those M4 holes. So we'll come along here to drilling, and we'll come along to hole making, choose our drill, choose an M4. I'm still getting around the new UI, but I think it's lovely. So we'll say equal to 4 mil. Excellent. So we'll say drilling. We're going to actually drill it with a, yeah, drilling tap actually would be better. We'll just drill it for the moment. No, we're not going to drill it for the moment. Let's do the right thing. We're going to drill it with a 3 mil. Hole making drill. Diameter equals 3 mil. Beautiful. And we're going to use that to cut these holes. Beautiful. And then we'll come along with another drilling operation. And this time we're going to use a tap. So we'll say hole making. We'll say right hand tap. Diameter equals to 4 mil. There we've got our tap. Tap, 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 tap. And we'll choose a tapping cycle. Excellent. Beautiful. Okay, so I think we're good. I think we're good. Um, the steep and shallow did not actually get this portion here. Not good enough. Let's see if we can convince it. Edit. Silhouette. Center boundary. Let's go ahead and say 8 mil just in case. And it's just calculating. Yes, laziness wins out. Okay, so wonderful. Let's go ahead and have a look at the two setups together in tandem. So we'll come along here, simulate, and let's go ahead and turn on the material. So we'll say facing operation, adaptive roughing operation. Comes in here with our first steep and shallow. Ooh, very nice. Comes along the bottom, steep and shallow, roughing. Ooh, very good. Roughing first. And now a proper steep and shallow. Oh, yeah. And then we come in with our, oops, still doing a very nice roughing part. Very good. Comes in with our drills. Drill, 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 drill. And then tap, 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 tap. Oh, beautiful. How did we do? How did we do? Let's go ahead. We'll say material, comparison. And here we can see the blue material shows material that's still to be cut. So I probably have to increase the offset at the end and then come in with a proper contouring on the right and maybe a fillet tool, form tool. But we're pretty much there. We're pretty much there. Not bad for about half an hour's work. Okay, unfortunately, that's all the time we have time for. So I hope you're keeping safe during this pandemic. Make sure you wash your hands, keep your social distancing. Continue to learn during this time. Develop yourselves. Now's the time to develop. Thank you very much for your time and your attention. I hope you learned something good, and we'll see you next time.